And in the left corner, I'm just kidding.
We're live now. Oh, there we are. So we're going to be going live soon. We got an in-person group, so we're just getting everyone settled down to their seat. We'll be starting at probably 6:10.
Very nice. How many people are on the stream and how many people are in the room?
26 on the stream, and probably we're figuring out in person because they're trickling in.
Okay.
All right, let's see. So we'll be right back. Hello. Thank you for patiently waiting. I totally appreciate that. Please welcome our presenter to talk about minimal APIs. And this is Rob.
Yeah, I am so glad that I get to be here. Are you able to hear me okay?
Yes.
Excellent. This is so much fun to be in Wisconsin today. Ooh, I can hear me in the background. That'll be cool.
That's why I muted my mic. Sorry about that. This is the first time we're going in person and hybrid, so we're figuring it out
Ooh,
now.
yeah. Well, welcome to everyone who's here in Wisconsin and everyone who's here from everywhere else. I'm so excited to be able to share with you minimal APIs in ASP.NET 7. So here's the part where I tell you I am definitely going to post the slides on my site tonight. So let's pull up my screen and I will show you my slides. So here's my screen. And in this talk, there are no slides. But the code that we're going to look at is online right now up on GitHub. GitHub.com/robrich/minimal APIs ASP.NET 6. Yeah, I probably should take off the 6 now because we're going to do .NET 7. But if it's easier for you to get there, you can head to robrich.org, click on presentations here, and here's minimal APIs with ASP.NET, and you can get straight to the code there. So, yep, it is online right now. Head to robrich.org, click on presentations, and you'll get straight to the code. While we're here on robrich.org, let's also click on About Me, and we'll learn about some of the things that I've done recently. I am a developer advocate for Shoreline. Both Microsoft and Docker have given me some awards. I'm also a friend of Redgate. AZ Give Camp is really fun. AZ Give Camp brings volunteer developers together with charities to build free software. We start building software Friday after work. Sunday afternoon, we deliver completed software to charities. Sleep is optional, caffeine provided. If you're in Phoenix, come join us for the next AZ Give Camp. Or if you'd like a Give Camp here in Milwaukee or wherever you're traveling from, hit me up on email or Twitter, or find me here at the user group, and let's get a Give Camp in your neighborhood too. Some of the other things that I've done, Pro Microservices in .NET 6. It was really fun to get to work with Sean and Matt on that book. And one of the things I'm particularly proud of, I replied to a .NET Rocks podcast episode. They read my comments on the air, and they sent me a mug. Woo! So there's my claim to fame, my coveted .NET Rocks mug. Oh, I also run some user groups in Phoenix and in Provo. So let's dig in. I'm going to come here, and we've got exactly one file in this. And let's open it up in VS Code, and let's build some minimal APIs. So I'm going to create a new file, program.cs. And here inside of program.cs, I'll say var builder equals web application dot create builder. Var app. Oh, yes. Thank you, VS Code. VS Code's going to add the .vs code folder. That'll help with debugging later. Var app equals builder.build and app.run. Well, we want to tell our app what to do. So let's also say app.mapGet. And we're going to map the home page to this function here. And so here's our function, and we'll say return, nope, we'll just say new message equals hello world. But what if we want to introduce ourselves? So let's actually take in a string, let's give it a name, and we'll make it optional because nullable reference types, that's excellent. And then we'll say, well, I want to say name, but what if you don't pass in a name? So I'll say or world. Cool. So let's come back to our terminal now that we've built that app, and we will say .NET run, and up fires up our web API. Now it does take a minute for it to compile, especially on web server. Here we go. .NET build and run. It's also restoring NuGet packages and doing all the things that we need to do. There we go. Let's head off to localhost 5000, and there is our API. Woo! Well, now let's do this. Let's say name equals wisconsin.net, and we get query string parsing. If we pop up our web developer tools, we can take a look at the request, and we can see that we have a get. It's returning the correct status code. It's returning the correct content type headers. We've got URL parsing. All of that in 4 lines of code. Yeah, that's pretty cool. And that's what we're going to build up to today. But this isn't the way that we've built our apps in the past. So how do we get from here to there? Yeah, that's going to be a thing. So let's stop this web server. And what we did just now was this bare minimum. We built that site. So if you want to replicate that site, here it is, program.cs and site.cs proj. Let's start then with an ASP.NET 5 site. And the balance of our talk is going to be upgrading this .NET 5 site to be a .NET 7 site. Oh, if I wanted to create a new project like this, I could say .NET new WebAPI, give it a dash minimal, and that will create a minimal API rather than a controller-based thing. Similarly, inside Visual Studio, I can go create a new project, and I can use this checkbox to enable or disable the minimal APIs. But we're back here in a .NET 5 project. So, yep, it says .NET 5 right here. And so we can upgrade this site to .NET 7. Now, .NET 5 is no longer supported, so you might have a .NET 5 project or maybe a .NET Core 3 project or maybe even older. And so it's cake to be able to get it to .NET 7. We could definitely come in here in Visual Studio and we could click on properties and we could pick it from the thing. But basically what we're doing when we upgrade from .NET 5 to .NET 7 is that. That's it. We just upgraded from .NET 5 to .NET 7. Now, as we do that, we might want to upgrade our NuGet packages. So let's come in here and we'll say manage NuGet packages. Let's take a look at the updates that we might have. Oh, it looks like we've got this one. Let's update this package and we'll accept the license. And now we're in .NET 7 and we've upgraded all of our dependencies. And so what's really cool is if you do nothing else in this talk, you will gain performance increases from that process. They spent a lot of work in both .NET 6 and .NET 7 and optimizing .NET to make it as fast as possible. Now that's excellent. They're using span of T to avoid allocations. They're parsing content a whole lot simpler. And so just upgrading from .NET 5 or .NET 3.1 Core to .NET 7 will get you some instant benefits. Well, let's start up this site. Now that we've got it into .NET 7, let's take a look around. Now, one of the interesting things in this website is that I'm using all of the paradigms of .NET. So we have a .NET MVC website, but we also are using Razor pages, and we're also using WebAPI. So here's our home page. We also have an About page. We also have a weather forecast controller that returns some JSON. And we also have a Swagger page that allows us to be able to try that out and execute against our web API. Well, let's take a look at how this works. First off, our home page. So here in our project, we have controllers. We have a home controller, and our home controller will then reference a view. So in our views project, we have home and index, and there's our view, and it shows us our home page. Now that is running inside of MVC. Also, we have Razor pages. So if I come here to my About page, we'll see that that is a Razor page. Now, Razor pages are perfect for doing things like, I just want to simply map from a URL to a file, much like we did in classic ASP. I just want to have a thing that exactly matches that piece. So here's our About page, and it works just fine. It references its layout page, and we've got Razor pages. We also have WebAPI. Here's our weather forecast controller, and it's spitting out JSON instead of spitting out HTML. Well, how do these things work? Well, here inside of program.cs, here's where the magic happens. How do we rig up, nope, not program.cs, startup.cs, there we go. Here in startup.cs, we start off by rigging up our controllers. And we say add controllers with views, so that'll get all of our MVC parts. Then down here at the bottom, we say map controller route. So we'll get our home controller by default, our index action by default. We're also mapping in an ID parameter. That gets MVC into place. Well, how did we get Razor pages? Well, here inside of our configure services, we said add Razor pages. That fires up Razor pages engine. And then after we mapped our controller route, we also mapped Razor pages. So our about page works correctly as well. Well, how did we get WebAPI to work? Well, here we're adding controllers. WebAPI is a controller, so we grabbed our WebAPI controllers too. But we also added our Swagger and our Swagger UI. We're doing this only in development just so that we don't accidentally expose our API publicly if that's not what we want to do. If we did want to expose our Swagger publicly, we could just move these out here and we would have a publicly exposed API documentation. So ultimately, our new file dialog really ought to be checkboxes of turning these things on and off, because we can use all three of them at the same time. Now, we just upgraded it from .NET 5 to .NET 7, and we saw how easy it was. But now we saw also that we upgraded all three paradigms. Our home page, our about page, using MVC and Razor pages respectively, and our Web API page that all still works out of the box from .NET 5 to .NET 7. Cool. Now let's take it a little bit farther and see if we can upgrade more pieces. We'll take a look at lots of really cool C# 10 features, including global namespaces, our file scope namespaces, implicit usings, global usings. We'll take a look at the new startup experience, and then we'll add minimal APIs as well. So our first stop is to upgrade our namespaces. Now we're here in this startup class, and we indent 4 spaces to get to startup, and we indent 4 spaces to get to our method, and we indent 4 more spaces. We're 12 spaces in, and we haven't even done anything yet. We also have a whole lot of this convention kind of baking this piece around. The majority of our .NET projects have a single namespace at the top, and that's it. They just define that namespace. So I'm going to hit a single key here. I'm here in Visual Studio, and I'm going to hit the semicolon. That's going to change this namespace to be a file scoped namespace. Now we noticed that in Visual Studio it unindented all of our files, which is really cool. Now we're only 8 spaces in before we do stuff. Now we could definitely argue about tabs and spaces and you maybe use less spaces, but yeah, we've just removed a whole lot of noise. Now if we have a project, a class file rather, that includes more than one namespace, maybe we have auto-generated stuff, we can still use the old syntax. It isn't broken in any way, and we can use some of each. So let's go build our solution, and we can see that our app still works. Let's run around to the rest of the app doing exactly that, using these file scope namespaces. Semicolon here, and here, and we've got a page here, and some code here, and here. Oh, not there. Oh, I already did that one. That's why. I'm not sure why weather forecast doesn't end up in the models folder, but that's fine. There we go. Now, we just moved to file scope namespaces. In our case, we chose to upgrade the entire project at once, but we could choose to do that slowly. The old syntax still works just fine. And if we really prefer the old syntax, we can definitely go there too. But that's cool. We've got now a lot more space in our software. Now, one of the things that we spend a lot of time doing is arguing about these using statements. Hey, I'm going to reject your PR because you didn't clean out all the unused namespaces. Or I'm going to reject your PR because you didn't sort them. Hey, did you add that namespace back in? Because now it's compile error. We spend so much time in our PRs fighting about should we add or remove these namespaces. And I grant my font is big, but I'm half a page in before I even get to the content that I want to do. What if we could centralize these? Now, there's no formal convention, but I'm going to choose to add a new file, and I'll call this usings.cs. You could also maybe call this global.cs, or whatever you wanted to call it. Now, I'm going to delete the class definition here, and instead, I'm going to go grab all of these using statements and move them into this global using file. And then I'm going to put global in front of it. Let's do that here and here. And am I hitting the right? Nope, I guess the key inside Visual Studio and VS Code is different. I'll do each of these, and now this using statement takes effect across all of the files within my project. Now that's great. I no longer need to specify using system in any file anywhere, which means now we have them centralized in one place, and so we don't need to worry about adding and deleting them all over our project. So let's go centralize all of our using statements. I'm going to come in here. We don't need that one. Here's the weather forecast. We don't need that one. Let's come grab the abouts, and we'll grab all of these ones, set them in our global using. I'll grab all of them from here and set them in our global using. Let's grab these ones. We already got those. Let's grab these ones, set them in here. And let's go grab these ones. And I think I got them all. 1, 2, 3, 4, 5, 6, 7. Excellent. Now, I do want to make all of these global, so let's do a little regex magic. The beginning of the line, I'll replace that with global space. Let's replace all of those. And now I did do a few things before, so let's go grab all of the globals and make them only a single global. Excellent. Cool. Now we've centralized all of our using statements. Now we may choose to have some specific usings in certain files if we're only really using that namespace in one place, and that will work just fine. But for all of the normal ones, putting them all in one place works great. And we can see it still builds. Excellent. Now I love the green squiggles here because Visual Studio is telling me that I already have these ones earlier in the file. So I can delete these. Those are duplicated. Those are duplicated. Those are duplicated. Here's some more duplicates. Let's remove these duplicates as well. And we're left with only a handful of using statements. Those are the unique usings across my entire project. Perfect. Now, we could have put this inside of a global.cs or a usings.cs, or even at the top of a normal file if we wanted to. But it's nice to kind of have them centralized in one place where we've got them here, where we can easily discover them. Build, and it works just fine. If we start up our website, we can see that our website runs just fine as well. ASP.NET, MVC, WebAPI, Razor Pages, they all benefit from this methodology. They all use the file scope namespaces, and they all have working pages in a really elegant way. Cool. Any questions so far? Any thoughts? Lots of questions about if this is being recorded. Yes, it is. Okay, so we've got a lot of using so far. Now, a lot of these we might say are going to be in every project everywhere. Do I need to specify them again? Yes, if we pop open our CS_proj file, we can see that based on this SDK, we can make some assumptions. Well, rather, Microsoft can make some assumptions. Every web project is going to need to have certain using statements. Every console app is going to have different ones. Every XAML app is going to have different ones. So let's opt into this. Now, if we were to create a new project today here in .NET 7 or .NET 6, it would do this automatically. But here in this project, we're going to say implicit usings enable. We did this because we upgraded it from a project before .NET 6 to a project that was .NET 6 or later. So we needed to add it manually. Now with this implicit usings, if we rebuild our project and then we come look at our output, let's come into the source directory. We're still upgrading this .NET 5 project. We'll go into the OBJ folder. We'll go into debug. We'll go into .NET 7. And we see right here, site.globalusings.g.cs. Here are all of the global usings that they automatically included for us because we have a website. Now, why does it have a global here and a global here? Well, what if I said namespace my app.global? That would be a global. And so they have this syntax to say, yeah, but it really is all the way global. And that's what this is. We chose not to use it because we weren't behaving badly with namespaces. Now I'm going to grab this. Temporarily, I'm going to set it at the top of this file here. And that will allow me to highlight all of the ones that are now automatically inserted for me. So let's delete all of these ones. Let's delete this one and this one. And we can see now that these are the unique usings that we need for our project. Wow, we went from half a dozen or a dozen or maybe more in each file to 6 usings across our entire project. That's pretty cool. Let's build it, and it still works just fine. Now, this is definitely optional. If you would rather put your usings inside of each file, you definitely can. If you have a name conflict, for example, 2 different libraries to find the class it, then you can definitely put the usings in the files that need those. And you can still specifically call out classes in this global using as well. But I really like centralizing all of my usings into one place so that I don't need to worry about it in any of the rest of my program. Cool. So now that we got our namespaces under control, we've got our usings under control, let's take a look at this startup class, and in particular, this program class. Okay, we know that every program everywhere starts with a static void main, and then it does this create host builder, which is apparently this method down here. There's a bunch of stuff that looks like, well, I don't know. It's a support system for this startup class, apparently. But then what is build and run? And then I get over to this file and it's like, well, why is this separate? What's this doing? I don't have a good sense of how these things flow together. Let's replace this with the new project initialization inside of .NET 6 and 7. So I'm going to delete this. I'm going to delete this. And let's say var builder equals web application dot create builder, and we'll pass in our command line arguments there. It can use that to be able to grab any parameters that we passed it. It's also going to pull in configuration details from environment variables and from config files and automatically build up that piece. Next, we're going to fill the IOC container, and then we'll say var app equals builder.build, and then we'll define the request pipeline, and then we'll say app.run. Wow, that was a lot simpler than the other one where we kind of jumped all over the place. Let's fill in these pieces. Well, we have this startup class here, so let's say var startup equals new startup, and startup takes in a configuration, so let's pass in builder.configuration. Now we need to fill the IOC container. Good thing we have this method in here that does exactly that, configure services. So let's go startup.configure services. We need to pass in a services. So let's pass in builder.services. We also need to define the request pipeline. That's startup.configure. It takes in the app. We have an app right here, and the environment, which is app.environment. And we now have the new runner using our startup class. Now, if we want to stop here, we definitely can. We could leave the startup class so that it kind of separates those two pieces. Or we could even take it a step farther and let's say, hey, this method isn't that big. I'm just going to remove it from here and set it in here. Now, it doesn't have a services. I could still say var services equals builder.services. Or I could just take it a step farther and say, I'll just call builder.services in each of these three places. Cool. Let's do that for the request pipeline as well. So let's go grab the request line. Now this one's a little bit bigger, so maybe I do want to have some extension methods that may make this a little bit smoother here. But for now, we'll just set it in place. We can also remove this use endpoints piece and just say map. And there's one place here, environment. So let's say app.environment. And hey, we just did away with this startup class completely. Let's delete that. And let's delete this. Cool. Now, if we like the old builder, we can definitely continue that way. That isn't obsoleted. It isn't removed from the project. But I find this new builder to be a little bit simpler. I now have a static void main, and I can follow exactly the process of how I fill the IOC container, how I build the request pipeline, and ultimately how I start my application. That's just simple. Now, we can take this a step farther and say, well, for the static void main in program.cs, I can remove all of this ceremony completely as well. And now this is a little bit of a cheater method because it only works in this one class. And so I'm going to get comfortable with that. And I'm like, well, can I delete it from here? No, you can only do this in program.cs. It does make the hello world a lot simpler, but should we keep the class definition and the namespace? I don't know. But yeah, this works just fine. Now, we've done a lot to take this ASP.NET 5 project and upgrade it into ASP.NET 7. We added file scope namespaces, we added global usings, we added implicit usings, and we added the new builder. But this project's supposed to be about minimal APIs, right? Let's do some minimal API stuff. So in the same project, together with MVC, together with WebAPI, together with Razor Pages, we can say app.mapGet. Now, the home page is already taken up by the home controller. So let's say API/minimal. And we're going to do a similar thing where we said, let's take in a string from the query string, name. We could choose to annotate it with from query if we wanted to, or from body. But I'll let .NET just figure it out. And we'll return a new object. Let's say message equals hello name. But if you didn't pass in a name, I'll say world. And that will be our minimal API. Minimal APIs run right alongside MVC, WebAPI, and Razor Pages. Now, there's just a simple one where we said, go run this Lambda. But let's do a little bit more. Let's say app.map post. In this case, I want to play with attribute routing. So I'm going to say /API/minimal/1/2. And I'll define these two parameters, much like I did here. And now in my Lambda, I'm going to say string 1, int 2. And those will be the parameters into this thing. So I'll return a new message equals 1, ID equals 2, and there's my post method. Well, now, what if I wanted to do more stuff in this method? So let's say app.map put, and I'll say /API/minimal. And here in this put method, I'm going to do more stuff. So I'll add a thing like this. Now I want to take in this, I'll actually give it an ID. And so I'll take in an int ID and an object data. And now I want to do some stuff. Let's go validate this object. And in this case, it's valid. But if it wasn't valid, then I would want to return 400. And otherwise, I'll save to database and then return success. Return 200. Okay, so how do we do these? Well, typically what we would do here is we would say return this dot add request. Well, that's not going to work in this case. This refers to this function right here. Now, if we were in a controller, we would have descended from controller base, and controller base would give us all of those things so that we could just, say return view or return okay. But here inside this minimal API, this method here doesn't have any bad request on it. Similarly, here we want to say return okay, and we want to pass in the object. And so I'll pass in a new thing, and I'll say message equals success, ID equals ID, and data equals data. Well, I would love to be able to do that, but this. Well, it turns out that we have this thing we can say results. And results then is this static object that gives us lots of different methods. So here's 403 challenge, here's forbidden, here's not found, here's JSON, all of the different methods that we used to have on our controllers overridden in interesting ways, we now have in this results. Now they all return an iResult object. And so as long as we return results dot, as long as we return a consistent thing, now both of these things will return this iResult. And in fact, we could return our own iResult. One of the ones that I like to do is to return a status code and a JSON body. The JSON one just returns a 200. So I could return a status code and say I want to return 400 or 418, I am a teapot. But how do I return both a thing and a body? I'll just go create my own iResult, and I can use that as well. Perfect. So now we have this minimal API that we can do, and it joins the other three methodologies for building ASP.NET. We have MVC that is perfect for being able to map URLs to complex objects. We have Razor Pages that is great for simple sites where we just want a URL to match a file and don't want to futz with it. We have WebAPI that is great for building JSON things. And we have minimal APIs that is also great for building JSON things, but, well, smaller. None of them are obsolete. None of them are going away. And, well, they kind of help us in interesting ways. So I want to add a base model here. I'm going to come in here to models, and let's add a new class, and I'll call this minimal model, and I'll give it a file scope namespace. Excellent. Public int ID get set. Public string name get set. Public minimal model data get set. Yes, I could definitely define a record class, and that would be awesome. We are using no, we're using nullable reference types. So we'll need to set this one as a default value, and we'll make this one nullable because we may not send it. Now with this minimal model, let's come back in here to our program.cs. And now I'm going to return a new minimal model, which means that one needs to be caps, and that one, and I'll need to set an ID. Let's set an ID of, I don't know, 7. And let's create a new minimal model there. This message and this ID. Did I not call it message? I called it name. Let's call it message. There we go. And now I can take in a minimal model, which means I can add data annotation attributes there and be able to validate my data in interesting ways. I now have a strongly typed thing. That's excellent. Perfect. We've added a little bit more structure to our minimal API, and we're still using things like attribute routing and dependency injection, automatic model binding, all of these features that we know and love from WebAPI or from MVC are just part of minimal APIs as well. Cool. Any questions so far on the project that we've built? Well, let's take a look at testing. I'm going to close this project, close solution, and we just live coded moving to .NET 7, namespaces, global usings, implicit usings, the new builder, minimal APIs. And so let's take a look at testing. We'll come back to more structure. So let's open up our testing one. And here in this solution, we have the site that we built previously, this test project. Now, just to save us some time in testing, in writing the tests, I created them previously, but let's start out with this unit test. Now, this unit test, I want to just flex the weather forecast controller. Well, the weather forecast controller takes in a logger and it returns 5 things. Now, I could do some wacky things to be able to take control over random, but in this case, I'm just going to say, I don't know what the temperature is going to be, but I know there will be 5 of them. So here in our test, let's do that arrange, act, assert pattern where we set up the scenario that we need to test. We do what we're going to do, and then we validate the way it's going to turn out. Now, in this case, I chose to also add in manage NuGet packages. I chose to add in not only XUnit, but also Fluent Assertions. Now, Fluent Assertions is a great library that makes it so much easier for us to build assertions. So in this case, I can say weather forecast.should.not be null. There was one test where I said assert.equal actual expected. Wait, no, should it be expected comma actual? I don't know. I spent a really long time trying to debug this test because, well, it said the value should be 7, and I kept getting 7, but the test said 5 is not 7, and I'm like, but I got 7 too. I had these values backwards. And with Fluent Assertions, here's our actual value .should.have count. We can just tell that story in a really elegant way. Now the cool part is, well, what if this is null? Well, these are extension methods, and as we build out extension methods, it might look like this: public static void, no, public static void should, and it takes in this object, and well, object could be nullable, but this should method just knows that that thing might be null, and it handles it appropriately. That's the way Fluent Assertions work under the hood. So perfect. We have this unit test, and we do need to create a new weather forecast controller. So I'm going to reach into MOQ or mock-U, and I'll just say I need an iLogger of weather forecast controller, and it's going to return me this fake thing. I don't care what's happening in it. That's not part of the test that I'm building. I just need something to satisfy this interface. So let's go .object, which will be that implementation of that interface that I need, and that will allow me to construct this new controller. Now, we could use auto mockers so that we can automatically generate mocks and override the things that we care about, but in this case, we'll just pass in that one. There's a unit test. Next, let's take a look at an integration test. Well, now as I start looking at integration tests, now I need to spin up my web server, I need to find an open port on my machine, I need to connect to that, there's a whole lot of plumbing in doing an integration test that I don't want to have to worry about. So new in .NET 6, and it works great in .NET 7 as well, we can create an instance of this app, and then we can create an HTTP client based on that app. And now, much like we would call anything else in ASP.NET on this HTTP client, we can call into various URLs. So let's just call API weather forecast. We'll go read the thing as a string. Yeah, I could read it as a JSON and deserialize automatically, but I wanted to take a little bit more control over it to deserialize it into a list of weather forecasts. Now, it might be null, might be blank, I don't know. So I'll deserialize it that way to make sure that I handle that correctly. Then let should not be null, should have count 5. And I'm going to use this assertion scope. That's a great new feature in .NET 6, C#10 that allows us to use using statements that just automatically expire at the end of the method, instead of specifically having to say, I want some more curly braces and some more indentation. We'll just use it the old way instead. The cool thing about this assertion scope is that it will run all of our assertions, and once that scope expires, then it will throw any exceptions about that, and all of them. If you ever run that test and you fix the one thing and you commit it and it kicks off the build and then it fails on the next line, I want it to run all the lines, show me all the errors, and based on all the errors, then I can go fix them and solve them. Thus, the assertion scope. So we just call into /API/weather forecast. It's going to do it in memory. It won't actually just flip to HTTP, but rather it'll still run the entire request lifecycle. So it's still doing all of the steps in our thing. It'll finally end up in our in our weather forecast controller. It will run the get method. It will serialize those results back out and come back in here, and we'll be able to read them. It's a true integration test without the WebSocket. So what does this fixture look like? Well, here's this fixture, and it's just a web application factory of type, well, that program that we have right here. We could choose to override services if we wanted to. Let's use a fake database instead of a real database. Maybe we'll use an in-memory database instead of an actual database, or maybe we'll spin up a new database for this test run. And then ultimately, we can build this thing. And now when we run our tests, we can do what we need to do. Similarly, if we want to test a minimal API, we can say, hey, I want to go to /API/minimal. I'll pass in name equals test. We remember that name equals test just returned that hello test in its body. So we'll read it, we'll deserialize it, we'll grab the assertion scope. Now, I wish I didn't need to do this, but .NET says, hey, that might be null. So yes, I did just assert that it should not be null, and then I threw an exception if it was null. Completely redundant, but it makes the compiler happy. And we hard-coded 3 into this API, so we'll validate that, and we'll validate that our name worked correctly as well. We could also validate our post experience. We could validate our put experience. And yeah, we're just creating a JSON body. We're sending it off in that request the way HTTP client works everywhere else. And we're able to write these unit tests in really effective ways. So let's build this. And we'll come here into our test window, and we'll go to our test explorer. I happened to pull it up previously right here. And so it'll automatically discover all of the tests in our, oh, hey, we got a build failure. Program is inaccessible. So I flip over to program, and yeah, it automatically generated this class. It automatically generated the method. And it's like, but I want to make it public so I can consume it elsewhere. Well, the cool thing is that it automatically built a partial class. And so I just need to implement the other half of the partial class. And so now that I've defined the other half of this partial class as public, now it will build just fine. I'm going to add a comment because that's just weird. Public for testing. And now if I build, now it'll build successfully. And let's fire up our tests. And we can validate both the units and the integration. And we have 4 passing tests. Woo! That was really cool. We were able to use this new fixture, so we didn't have to find an open port. We didn't need to do anything weird there. We could just say, run it. Ooh, we have a few questions. Jason, what would you like to ask? Does C# 11's required members also have an influence on model validation? Yes, it's actually a compile time fail rather than a model validation fail, but that is a great question. So for example, here in my minimal model, I could have said rather than setting its value like this, I'm just going to say required. And yes, that makes that so much simpler. Now I don't need to give it a default value. Excellent question.
Thank you. We have one more question.
And yes, that makes that so. I've never used VS Code for C#. Would you explain the usage of VS Code or Visual Studio? Great question. Visual Studio and VS Code work ever so slightly differently, but they ultimately use the same C# under the hood. You'll notice that when I run build, it here in the output, it says, hey, I'm building and I'm doing all the things. 2 succeeded, 0 failed. If I were to come in here into the, that console window is done. If I come in here to the console, SRC, I'm in step 9. I could say .NET build, and that would yield the same experience. You'll see that the output looks really similar. Whether I choose to use Visual Studio or VS Code, I can have that same C# experience. Now, why would I choose VS Code or Visual Studio? Well, VS Code focuses less on designers and more on code. So if I really want to, just code, then I might choose VS Code. If I like the designers, if I like the ability to automatically navigate between things, then I might choose Visual Studio because, well, it has more designers, more bells and whistles. It's kind of a higher end thing, but it's also a little bit beefier. So if Visual Studio is really hindering my machine, then I might flip over to VS Code and build content there. Ultimately, it's the same C# in either side, so it's a preference that you can choose. That's a great question.
So we have one more. It's not a question, but some feedback about the assertion scope.
Assertion scope is so good and I love it. Fluent assertions is amazing. I completely agree. Yes, as soon as I found assertion scope and fluent assertions, well, I found fluent assertions for the test syntax, and then I started using it inside of assertion scope, and I'm just like, yeah, that is so cool. Cool. So let's close this solution, and we'll open our .NET 5 project back up. Now, I've got my program.cs, and it's getting to be 57 lines long. That's a little bit big. Let's see if we can, I don't know, abstract this out a little bit better. We've got some stuff. Maybe we want to use our environment pieces in different ways. Maybe we want to create extension methods for this. You can actually do this in C# 10 and .NET 6, which is excellent as well. But our focus here is about this minimal API. So let's go grab that minimal API piece and see if we can move that somewhere else. I'm gonna, I don't know, I'll just make up this APIs folder thing. I'll add a new class in there and I'll call this minimal.cs. And now, oh, file scope namespaces, excellent. Let's do some stuff in here. I want to take this method and I'm gonna turn it into a map get method. So public minimal model get. There's my get method. Let's comment this out just so that C# won't get so mad at me. Let's do a post method. Oh, that's a little bit too far. There we go. Public minimal model post. Thank you, GitHub Copilot. There's our post method, public I request, nope, I response, I result. Put, and let's go grab this put method and we'll put that here. We don't have the arrow anymore because it's actually a method with a body. Okay, so we now have 3 methods in place. And so let's, I don't know, I'll go invent something, public void init, and let's take in a web application app, and let's initialize it. So I'll say map get goes to the get method, map post goes to the post method, map put goes to the put method. Now, if we had, I don't know, a dozen models and we had 4 methods per model, then yeah, our program got really big. And so this might be a way to kind of contain that. Well, back here, we can say var minimal equals new minimal. Oh, hey, we need a new using statement. So we could get it to automatically insert it, but I'm actually going to take it out of here and put it inside my global usings. Global using this new thing. Now that I'm here inside program.cs, we can say we've got this minimal.init, and we'll pass in our app. Or I'm going to try to one-line this so that we can avoid the merge conflicts. Or we can even just say app.services.getRequiredService, which will do all of the dependency injection things that we need. And now that we have that, we can initialize it as well. Cool. Now all the merge conflicts of we each added the thing to the end of the file just kind of melt away. And now we just have this one-liner that puts that content into place. Yeah, we may still merge conflict on this one line, but I think that's a little better. But let's come back to this. What does this look like? Well, if I squint real hard, this looks like a controller. To that end, maybe I should take the extra step and just say controller base, and well, now it's a controller. Yeah, I think we went a little bit overboard when we did this. This probably isn't the right use case for minimal APIs. Now, we did put a minimal API inside of the same project as WebAPI and Razor Pages and MVC, just to show that we could. But this is probably not the right use case for minimal APIs. If you have more than, say, half a dozen models, more than, say, a dozen or so routes, then minimal APIs probably isn't the right fit. You should probably use WebAPI. In a similar way, if you want to upgrade to something smaller, you might choose to use Azure Functions or maybe Knative Functions. And if you want something that's, well, the right size, a smaller project, then maybe minimal APIs is perfect. So let's close this solution. We just did more structure. Now let's take a look at the right size project. So let's open up right size. Now with this project, we have this goal. We have some interesting config file, and we want to get this file online. Or maybe we have a webhook and we just want to accept some form post and transform some data and save it somewhere. Or we have a website that just needs to have that send email functionality. Or we just need to do that one little thing online. So let's see what we can do. Now here in this application, we have exactly one C# file. We don't have any other files here. We just have program.cs. Even inside properties, it's just the launch settings.json file. Is it going to let me open it? There we go. Launch settings.json. Only one C# file. So let's take a look inside that C# file and see what we can do there. Well, here's program.cs. Now, we did the web application.create builder. We didn't need a class definition or a method definition. We wanted to map this slash to be able to go grab this interesting config. Here in this method right here, I just added curly braces to make sure that I didn't accidentally cheat and grab this, but I just said, let's go read that interesting config. Now, I did deserialize it into a strongly typed object. So we've got this record here, and it will just create all of those parameters for us, all the properties. So we are deserializing this object into a real object. I'm going to throw if that's null because I want my site to fail. I want the pod to fail. I want Kubernetes to notice that this isn't running and let me know. But hey, if I've got an interesting config and I deserialized it correctly, let me just stick it inside of the IOC container so that I can just pull it out whenever I need it. So I'll add it as a singleton. I don't need to reinitialize it every time. And now I'm going to go grab that interesting config and return it. I think this is about the right size for an application. So let's run it. Let's see if we can get our application going. Now, the cool part here is as we run our application, we want to be able to pull up that interesting config. So here's our app started up, and we'll go to the home page, and there's our interesting config. Yep, we were able to accomplish the goal. We've got our site online. But any site that's worth it probably needs, say, some Swagger details too that allow us to be able to flex it. So let's go execute that. We can see that we get our interesting config. How did we rig that part up? Well, here inside of Visual Studio, I'm going to say add endpoints API Explorer and add Swagger Gen. Down here, we use Swagger and Swagger UI to be able to generate the Swagger details. And so it automatically reflected across all of our routes, pulled in the details, and it was able to identify then that we had this method that we wanted to expose. Well, what else might an API need to do? Well, we probably want to handle errors. So let's say we'll go to an error page and we get a 500. Excellent. How did we do that? Like we do in every template, we want to, in development, use the yellow screen of darn. But in production, we want to use this exception handler. So it goes to /error. So we just came down here in minimal APIs and we said map error to results.problem, the 500. Well, a good API probably also wants to do a not found page. So let's go to not a valid route here. And we get a 404 page. How did we do that? Well, we just said map the rest of them. Here's that star that says map anything else that we haven't figured out in the URL. So we might say my page and then grab the rest of the URL. It'll grab all of those things, including all the slashes. In this case, we just said, I want to map any URL that you haven't found, and I'll return not found. Now, the first time I did this, I actually didn't have this part. And so it just returned Chrome's default 404 page. And I'm like, well, is my site connected or is it working? Nope, I needed to return some JSON so that I could tell myself, hey, this doesn't work. Well, what might another API need? Well, it probably needs a health check page. So let's go to the health check page and we can see that it's healthy. We could choose to expose additional details or maybe expose these as JSON. But now Docker can monitor my application. And in case my process is unhealthy, it can terminate that container and restart it in a really elegant way. How did we rig that? Well, up here at the top, we chose to say add health checks. And we chose to expose our health checks on the /health URL. We have our business need met. We have 404 handling. We have error handling. We have health checks. And we have all of this, including a strongly typed deserialization class and the line we need for testing in 46 lines of C#. One file, no class definition, no namespaces, all in one file. This is the perfect use case for minimal APIs. If we have a bunch of models and we have a bunch of endpoints and we need to do CRUD on each one, then we probably want to upgrade to WebAPI. If we have an even smaller task that we need to do where maybe we just need to drain a queue or accept a form post, then maybe Azure Functions is the perfect way to upgrade there. But if we just need a little task and we want to take a little bit more control over that process, then minimal APIs is the perfect use case for that allows us to build these really small single file applications. We don't need a whole lot of ceremony. We just build our app to accomplish the task. In this case, we had that interesting config we just wanted to get online, and we could do it in one C# file that was only 46 lines. This is the right use case for minimal APIs. Ultimately, though, minimal APIs joins the other things that we found. We can use WebAPI, we can use MVC, we can use Razor Pages, and now we have a fourth paradigm inside of ASP.NET, minimal APIs. Let's use the right task for the tool that we need, the right tool for the task that we need. And if it's minimal APIs, if it's a small task, that's perfect. If we need more bandwidth, we can upgrade to WebAPI. If we need more of a static site, a marketing site, maybe we'll use Razor Pages. And if we want to do interaction with HTML, then we'll use MVC. Each of these four paradigms is great for the task at hand, and each of them is able to accomplish some really elegant things. Now, the cool part is this website is online right now. All of the code that we built tonight is online right now. We went through each of these chapters. You can grab it from github.com/robrich/minimal-APIs. If that URL is a little bit too long, head over to robrich.org, click on presentations, and you can get straight there as well. If you're watching this on demand, hit me up on Twitter at @rob_rich or contact the meetup organizers, and let's continue the conversation. For those of us who are here live at the event, either in person or online, what are your thoughts? What are your questions? Where do you want to see minimal APIs go next?
So we do have a few questions, so I'll bring them up.
Where do you want to see minimal APIs go next?
Here we are. So we have a
few questions, so I'll bring them up.
We have a few echoes too. We also have startup.cs and program.cs in .NET Core. Will your changes, global using namespace combination, work in .NET Core as well? Yes. Now, the cool part is that we chose to upgrade to the new startup experience, but we could have left it the old way as well. We could have left that separation between program and startup. And you notice that in that intermediate spot, I did use the new program.cs parts, but I called in the startup. So if you like that abstraction, then you can keep that as well. But it is a simpler experience. Ultimately, though, if the only thing you want to do to get performance gains is just go into your CS proj and upgrade it from .NET 5 to .NET 7, you'll still get performance gains. And everything else we did today was optional. Great question. How would you decide if you wanted to use minimal APIs in an enterprise software? I usually use REST APIs. Could minimal APIs be used in some cases? Yes, minimal APIs is definitely enterprise grade and high quality, high performance for the needs that you need it to be in. But I would argue in most cases, if you have an enterprise application, a very large application, minimal APIs is probably not a good fit because we're going to spend all of our time merge conflicting because I'm going to add my new methods at the end of program.cs and you'll add your new methods at the end of program.cs and whichever of us gets our merge in first is going to win, and the other one's going to hate this. In that case, when you have a very large application, use controllers. They're right there, and they work just fine. If you have that one little thing that just needs to go in, maybe you could add a little minimal API inside of your enterprise application, but probably controllers are a better fit. Now, ultimately, where is that line between them? I would invite you to do some experiments, see if you can find it, and you'll definitely be able to gain some confidence and some experience there. Ultimately, yes, you could use minimal APIs and stop using controllers completely. I would argue that's probably not a great choice. Controllers aren't going anywhere. They aren't deprecated. They aren't removed. They're still a great solution for larger enterprise applications. Great question, Monica. How can we secure the API endpoint mapping in minimal API? Is there a new approach to make other mappings secured for authorized users only and others can be used anonymously? Great question. So let's come back to the project that we were doing before. Yes, I'll save that. Oh, it wants to save my solution file. I'm going to say, nope. File, close solution. Yep, I don't even need a solution file, just a CS proj file. Let's come back to this original one. Now, in our API controllers, we can put an authorize attribute right here. And now you must be authenticated to use any of these the methods inside this controller. Or I could put it right here and say, now you must be authenticated to use this method, but other methods in this class are okay. Well, how do we do that with minimal APIs? So back here in program.cs, I moved it over into this abomination thing. No, because in the majority of cases, you're actually going to not have it here. You're going to have it here. And well, we can't really put it here because, well, there isn't a whole lot to this Lambda. It's just kind of, dangling out there in the same way that we didn't have a this. And if I were to put it here, it's like, well, that kind of doesn't work either. So the way that they do this is they say dot require authorization. And you can give it details about what rules are required for that in the same way that in the authorize attribute, you can give it roles. So you can say, hey, I want it to work in this particular method. Here's the authorization policy. Or we can take a look at just passing in policy names. All of the ways that we could configure the authorize attribute, we can use this dot require authorization one. So in this case, the get requires authentication, post and put do not. I could choose to, add that to these other ones as well. So now post and put do too. But ultimately, that's the methodology for securing minimal APIs in the same way that we secure controllers. Great question, Christian. Can you talk about using async with minimal APIs? Yes. Let's put this post method back as well. And let's put the put method back just because, these things are bugging me. And let's say that we want this one to be async. Oh, we need the arrows as well. Because we're going to say save to the database db dot save async in entity framework. So we're going to want to await this. And so we mark this as an async method. And now it's an async minimal API. Yeah, I don't have a DB class, so I'm getting it squiggly right there. But that's it. It is just that simple. Any of these methods, no matter what we do, we could choose to make them async. And now we have asynchronous minimal API methods. Great question, Kevin. Does .NET 7 support sharing internals instead of opening up program scope? Yes. In this case, we came in here to program.cs and we said public partial program to be able to get access to it in our tests. We could have instead said here in our project, internals visible to, I think it might need to be in its own item group. And now I can make that private class exposed publicly to my tests instead. I tend not to use this just because it's a little bit less discoverable. I know that this thing is an abomination. It just looks ugly. But one little comment about for tests, and I'm not bothered by it as much. But I agree, using internals visible to is a great alternative to creating that other half of the partial program. Good call. Can I show the minimal CS code file? This one right here? I'll even do you one better. Here it is on GitHub. And so before we did all of that more structure piece, here's those minimal APIs, and they're right here inside of program.cs, where I just said map get, map post, map put, and so we were able to grab that data. And so that's right here as well. It's all up on GitHub, github.com/robrich/minimal APIs ASP.NET 6. And if it's easier, you can head off to robrich.org/presentations, and that will get you there as well. Great question, Deepak.
I think that's all the questions, and that's all. Thank you very much.
Awesome. I had so much fun getting to share with you minimal APIs in ASP.NET 6 here in ASP.NET here in Wisconsin. Thanks for including me in the group.
Thank you.